You know what I hate? Math. You know what I really hate? When I spend hours making a math slides presentation and then I wait too long to record it and my graphs and my formulas disappear. So I guess I'll force myself to go ahead and record this. This is Quadratic Functions in Context, Unit 4, Lesson 6. Quadratic functions come in different forms. There's standard form, vertex form, and factored form. Standard form, oh, I never put these formulas in here. Yeah, I'm amazing. Standard form is when A is the leading coefficient, B is the linear coefficient, and C is the constant term, which is also the y-intercept of the graph. We'll see these forms later. I'm not even going to bother going to put them in now. Vertex form is when A is the leading coefficient, HK is the xy ordered pair for the vertex or the turning point, and factored form is when A is the leading coefficient and x1 and x2 are the zeros of the function. And that one I actually put the formula in. It's f of x is equal to a times x minus x1 and then x minus x2. And just so you know, these x1s and x2s were really little at one point, so I'm starting to worry that this is going to be a mess. Here is example 1. A farmer is planning a rectangular plot to test growing a crop of chilies organically without synthetic pesticides or fertilizers. The plot is 100 meters by 200 meters. As part of pest management, a border of the plot will be planted with protective crops to keep insects from spreading disease to the chilies in the center. I'm bored. The farmer wants at least 95% of the plot left over for the test crop. Write a quadratic equation for the fraction of the plot remaining for the test crop with the width of the border crop as the variable. Then solve that equation to find the maximum width of the border crop. Who cares? But anyway, we'll do it because they're making us. Let t represent the area of the chilies and x represent the width of the border. The chilies form a rectangle that has a width and length shorter than the full plot by 2x. Now, why they knew that, I have no idea because I don't have a math brain, but sure, it does. The area is the product of these dimensions. Okay, that I get because area is length times width. Okay, so maybe that's why 2x. I don't really know. Anyway, this is our formula, and they want us to simplify this and then write it in standard form. So I think I can handle that. Hopefully my brain's functioning enough to do that. So what we need to do is we need to distribute this out to each of these, and then we'll do the same thing for 2x. So we have t of x is equal to 200 times 100 is 2, and then we take all of the zeros. So 2 zeros from one and 2 zeros from the other. So 20,000, okay? Then we have 200 times negative 2x. So we have minus 400x, okay? There's our first set. Chunk, chunk. Now we need parentheses again, and we're going to do this one. And it's going to go to both of these. I'm drawing really nice arrows. Okay, so we have negative 2x times 100 is going to give us negative 200x, okay? And then we have negative 2x times negative 2x is positive 4x. Now, we've already multiplied all of this jazz, so we don't need those parentheses anymore. I put them in because I am left-brained. Oh my goodness. Okay, this was 200,000. I wish my my eraser was a little more precise, but it's not. This was 200x. Okay. And just ignore this last one. Well, let's see. Maybe I can erase it. Haha, I didn't take everything out. So it's just a formula written like this now. Now we need to just add like terms so we can simplify. So we still have t of x, that looks like a 7, is equal to, okay, we have a number all by itself, which is just going to have to stay by itself. But it's going to end up on the end of the problem because you write it in like x squared, then x, then, so I'm going to write it over here. Okay. So 200,000 is going to stay there. Now we have all of these x's. Did we really? No, we did have an x squared. This one is x squared. 2x. No, 2x is, okay. So that's going to be our first number. That's going to be 4x squared. Am I confusing you? Because I'm confusing myself. And then these two can be combined, so it's minus 600x. This one's a positive, so we'll put a plus right there. This should be our formula. Let's see how badly I screwed it up. 4x squared minus 600x. Oh my gosh, I actually did it right, guys. That's scary. So the area must be at least 95% times the area of the full plot, okay, which equals 200 by 100. The full plot is 200 by 100, but we can only use 95% of it for the chilies, okay, because that's what all this garbage said. So we're taking this original bit that we had from over here, the 200 minus 2x, 100 minus 2x, okay, and we're setting it equal to 95% of the plot, which is 200 by 100, okay? Now, I don't know why they're doing this to me, why they're making my life so hard, but it says before multiplying, notice that both sides are divisible by 4. Why? Why? Why are you making me do this? Just stop, just stop, just stop, just stop, just stop, just stop, just stop. No. Why make my life so much harder than it has to be? I just don't understand, okay? So this multiplies out to be this majigger, okay? And I guess if we divide all of this by 4, 4 divided by 4 is going to give us just x squared. 600 divided by 4, I guess it could be 150, 150, 300. Okay, yeah, that makes sense. 20,000 divided by 4 would be 5,000. So they took this and then they divided the whole thing by 4 to get this side of the equation. Now this is what I don't understand. Because they said that you can divide both sides by 4, but if you're dividing both sides by 4, don't you have to divide this 95% by 4? But they didn't. They only divided this bit by 4. Whatever, book. I would have just left it alone and not made it more complicated than it had to be. But they decided to be a pain in my butt, I guess. Okay, so now, anyway, we can simplify this side. This side is left alone, but we have 50 times 100 is going to be 5, and then you keep all the zeros, so there's the 50 and here's the 100, and then we're going to take that and we're going to multiply it by 0.95. So this is how many square feet there should be in the majigger. And does that still make sense? Because they screwed with it, because it should have been 20,000, but you know, whatever, you do you, boo, because they messed over here. You do you. Okay, so now we need to find what 95% of 5,000 is. And I've got this blown up really big because I used a smaller font size. So I'm going to have to like pause this and then come back. This is going to be really fun. Hopefully I don't screw this whole lesson up. Okay, so if I do this math, it ends up being 4,750. So this is the amount of space that we should have available for the chilies. Okay, we can plant this amount of square footage to the chilies, but this still doesn't make sense to me because they did this stupid thing, and we really have 20,000 square feet, not this, so it should be like twice this that we can plant as chilies, but whatever, this is what they're showing us. Okay, so now what we have is we have so we still have here x squared minus 150x plus 5,000. And it looks like they want us to get it down to have 0 on one side. So I guess if we add this over here, that would give us a really huge number, but somehow they ended up with 250. The x squared and the 150x all stayed the same, but they ended up with 250. Which doesn't make sense to me. Because if we subtracted 5,000 from both sides, then we'd have a negative 250 over on the right. And then if we added it, we'd get it over here. So maybe, okay, maybe 250 does work. You guys, I'm not a math person. Anyway, we get this formula. So the quadratic expression on the left can't be factored. I don't know why, but I hate factoring, so yay for that. So the quadratic formula is necessary. This is the quadratic formula. I hate that they're bringing all this garbage back. I hate this trash. Okay, so this is A. A equals 1. B equals negative 150. And C equals positive 250. So I found all of these. Now I need to use this formula to solve. Oh my gosh. Did I mention that today is day 2 of a migraine? But let's do this fun stuff. Okay, so negative 150. I'm using the formula up here. Plus or minus, because we're doing a square root. And you have to do that for whatever reason. Another B, which is negative 150. Squared minus 4 times A, which is 1, times C, which is 250. And I need to extend this, and this whole shebang is getting divided by 2 times A, which is 1. I'm going to go grab my phone to use as a calculator. My phone is charging, so now I'm using my absolutely massive Kindle as a calculator. I am not going to win today, am I? So we still have x equals negative 150 becomes a positive 150, plus or minus the square root of negative 150 squared is 150 times 150. Two negatives become a positive, and that gives us 22,500. Okay, wow, I'm such a good writer. Negative 4 times 1 is still a negative 4. Negative 4 times 250, let's try that. 4 times 250, it's still going to be a negative, so it's going to be minus 1,000. Okay, this is still under that square root sign. And then this is supposed to be A, which is 1. I wrote that stupid, divided by 2. Okay, let's continue solving. So we still have 150 plus or minus the square root of 22,500 minus 1,000 is 21,500. I almost made it long enough that time. Divided by 2. I derailed and did it wrong, so I had to stop so we can start again. Okay, so the square root of 21,500. It doesn't tell us how many decimal places to go to because, this book sucks. But we still have the 150 plus or minus, and then we'll go 146. They usually just go to the 10th in this book, so I'll go to the 100th. It's 628, so we'll go 63. Okay, divided by 2. Now this is where we get two answers because we have this plus and this minus. So what we're going to do is we're going to go 150 plus 146.63, which is 296.63, and we're going to divide that by 2, and that's going to give us our first answer, which is 223.315. Now we need to find the second answer, okay? So we have 150 minus 146.63, which is 3.37, and we're going to divide that by 2. Oh, wait, I'm doing this wrong. This calculator is different, so this number's probably wrong too. My other calculator, I could just keep going, but it's doing stupid things. So let's do the first one again. 150 plus 146.63 is 296.63 divided by 2 gives us 148.315 for our first number. Okay. Now for our next one, we have 150 minus 146.63, which gives us 3.37, and we're going to divide that by 2, which is going to give us 1.685. Okay, let's go see what this has to say. So we have 148,314. Oh, they said 31. I put 315. Apparently they don't believe in rounding, and 1.68. Yeah, apparently they didn't round. I love this book. Rounding is a thing. The huge border does not make sense in the context, right? We're not going to have a border that's 148 meters wide. I mean, that's insane. So the maximum border is about 1.7 meters. So you need to take into consideration the context of the question. If you have, you know, like a 100 meter by 200 meter, you're not going to make a border that's 149 meters. That's obviously not reasonable if you're going to have this be 95% chilies. That's not going to work. Okay? So there's example 1. Thankfully, the rest of these aren't as stupid as this problem. Okay, here's example number 3, because 2 was a video and I don't do videos. Forget them. The main span of the bridge, which runs between the 2 towers, the curved suspension cable is roughly in the shape of a parabola. The towers are 3,500 feet apart. The tops of the towers are 604 feet above the river and 327 feet above the vertex of the parabola, the lowest point of the cable. Because all parabolas are symmetric about the axis of symmetry, which goes through the vertex is halfway between the towers. Write an equation for the height of the cable above the river. So we want an equation for the height of the cable above the river as a function of the horizontal position along the main span. Let the center position represent x equals 0. So the vertex is going to be x equals 0. We're pretending that we've got a graph, a coordinate plane back here behind this thing. Use that function to find the height of the cable above the river halfway between the center of the span and a tower. Okay, so it wants us to write an equation and then it wants us to find here, the point here. Okay, we'll do it together, don't panic. The x coordinate of the vertex is 0. Okay, remember we did that already. X equals 0. We decided that at the beginning. Because the tops of the towers are 604 feet above the river, and the vertex is 327 feet below them, you can find the vertex's y-coordinate as 604 minus 327. So the y-coordinate for this right here, okay, that would go side to side, is 277 feet. So this coordinate is 0, 277 if we had this with a coordinate plane floating behind it. Okay, this point would be up, this y point right here would be 277. Okay, because you know the vertex is at 0, 277, you could use the vertex form of the quadratic function, which is right here. I didn't put that on the beginning slide, but this is the vertex form of the quadratic function. This should be in your notes. It's not in mine because I don't actually have a notebook because I'm a failure at life, but I'm probably going to need it, so I should write it down. In this form, v of x is the vertical height above the river, x is the horizontal position, 0 equals center, h is the x-coordinate of the vertex, in this case 0, k is the y-coordinate of the vertex, in this case 277. Substitute and simplify. So we know the x and y coordinates, so x goes right here, y goes right here because x and y are also h and k. That should be in your notes, okay? And now that we have this information, it can be simplified. So 0 times 0 is 0. So then it's just a squared, ax squared, okay? That's another way of writing it. So let's continue. Now find the coordinates of a tower. Because the parabola is symmetric with respect to the y-axis, okay, you can choose either tower. The x-coordinate of the right tower is 3,500 divided by 2. Because we're going halfway, okay? So 3,500 divided by 2, which is 1,750, okay? So the y-coordinate is given as 604. So this would be 1,750, 604. That's the coordinate for that one, okay? Substitute these coordinates into the equation to solve for the remaining parameter. So if v of x, the x value is 1,750, so v of 1,750 is equal to a times 1,750 squared, okay, because this is our original problem, plus 277 is equal to 604, because that's what we know the x value is, the y value. Okay, so now we can go ahead and solve. So 1750 squared, let me get my calculator up again, my thing went to sleep. 1750 times 1750 is a big old number. This becomes 3,062,500 a squared, don't lose any of those pieces, plus 277 is equal to 604. Now we need to solve for a. Okay, so the first thing we need to do is, let's get rid of this 277. Let's go minus 277, minus 277. Okay, that's going to leave us with our 3,062,500 a squared is equal to 604 minus 277 is 327. Okay. Now we're going to end up with some really horrible number here, right? It might have wanted us to get it to 0 here. Let me go and peek. Nope, it wants us to get it to the really horrible number. So we're going to divide both sides by this 3,062,000. So 327 minus 3,062,500 gives us a squared is equal to 0.0001067, and they have not been rounding, so I won't round. I'll just leave that at a 5. That goes on forever and ever and ever. We're going to find the square root of this. Okay, 0.000106775 is going to give us a being equal to 0.01033. Let's see if they agree with us. Oh, they just stopped. They just went here. 1068. Yeah, okay. And they rounded that time. I don't know why. So they left it at the a squared. So they have blah x squared plus 277. I'm not sure why, but you know, you do you, boo. Check the function by calculating the height at a tower. So this is our new formula. Sure, you do you, boo. I guess this was our a. Oh, because we solved for a. So this was our a value. They didn't take the square root of it for whatever reason. I guess because we're left with x squared and we want x squared to stay. Maybe that's the logic. We get it down to a squared is equal to 1086. So we have this problem. So we're going to do 1750 squared again, which I don't remember. 1750 times 1750 gives us our, so we have 0.0001068 times our 3,062,500 plus 277. So we're going to take our 3 million number, we're going to multiply it by that decimal, which is 0.0001068, and that's going to give us 327.075 plus 277. So we'll add those two together, which is going to give us 604.075. So what that's saying is the height of the tower is 604.75 feet. Is that right? Yep. There we go. The x-coordinate halfway between the center of the span of the right tower. We did that. I think let's substitute this value in for x. So we got that. Okay, we got the 604. So now they want to know the halfway point. Okay, we figured out the halfway point between this center point and the tower. I'm guessing all the way to the water was 875 because it's 1750 divided by 2. Okay, so now we're going to take V of 875 is equal to our decimal place times 875 squared plus 277. So let's take our decimal place, 0, 0, 0, 1068. Oh, no, sorry, we have to do the square first. Delete, 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 delete. 875 times 875 gives us, we have blah, 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 times 765,625. Okay. Plus 277. So if we take our 765,625 and we multiply it by our decimal, which is 0.000168, that's going to give us 81.76875 plus 277. So we'll add those together, and that is going to give us our final of 358.76875. And just so you know, so they said 359, they just rounded up. Just so you know, I'm extremely lost, so I hope we don't have to do anything this complicated. Notice the many vertical cables that attach the roadway to the suspension cable. The length of each vertical cable is a function of the height of the suspension cable above the roadway, so your function can be used to calculate the amount of vertical cable needed. I'm so happy about that, and I hope I never have a job that requires me to do that. Here is question 1 that is all you. Oh boy, I have a feeling we're in trouble. An interior designer is shopping for a rug for a client. The client currently has a 5-foot by 6-foot rug with a pleasing design, but they ideally would like to find something with a 40% greater area, with both dimensions increased by the same amount. Create a quadratic function and solve it to find the dimensions of the new ideal rug. I hate you people, just buy a bigger rug. Okay, pause it and see if you can figure it out and then come back. I'm hopeless. Okay, this is what it says. The area of the current rug is 5 feet by 6 feet. And area is just length times width, so 5 times 6 is 30 square feet. The current rug is 30 square feet. I can get all this. Check. That all makes sense in my brain. The ideal new rug is 5 plus x times 6 plus x equals 30 times the whole rug plus an extra 40%, so 1.4, which 30 times 1.4 is 42. So the ideal new rug is 5 plus x times 6 plus x is equal to 42. Okay? The quadratic equation in standard form is x plus 12 times x minus 1 equals 0. Now this, I'm guessing, is this, like, I don't know. Let's see if I can figure this out. So if we have 5 plus x, I'm going to try writing this in standard form and then seeing if it factors out to what they have. 6 plus x equals 42. Okay, let's try writing this in standard form. 5 times 6 is 30. 5 times x is 5x. X times 6 is 6x. And x times x is x squared equals 42. So let's subtract 42 from both sides because I know we want 0 on this side. So what we end up with is on this side we're going to have 0. The difference between 42 and 30 is 12, so this is going to be negative 12 down on this end because we have to write it in the correct order. X squared is going to be our first number, and then 5x plus 6x is 11x. So this is our final formula, okay? This is our beautiful little, now can this be factored out? The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, now which of these is going to give me 11? It would obviously be these two if you have like a positive 12 and a negative 1, which they have here. Okay, so that's how they found that. Check. This makes sense. Okay, so quadratic equation in standard form. The negative root x equals negative 12 does not make sense in the context. Okay, so if we have this majigger, then saying, oh, so if we factor this out, then this means that our values for x are x is equal to negative 12 and x is equal to positive 1. Okay, so these are our two possible options for the new rug. Like the new rug could be like 12 feet, negative 12 feet, like x for this formula could be negative 12, or x could be positive 1. Negative 12 doesn't make any sense because you can't have a negative sized rug. Does that make sense? 5 minus 12 is going to give you a negative number. 6 minus 12 is going to give you a negative number. You can't have a negative rug. So the larger rug would be 5 plus 1, which would be 6, and 6 plus 1, which would be 7. So it would be 6 by 7 feet. Okay, I was able to talk my way through this. I hope this made sense to you. Okay, I'm hoping there's nothing like this on the end. I don't remember there being anything like this on the end. So don't stress too much. Okay, here is another question. I'm guessing this is number 2, even though I listed it as number 1. Okay, a highway engineer is designing a 100-foot wide parabolic arch bridge over a 2-lane road with bike lanes in both directions, as shown in this illustration. For trucks to pass under the bridge must be 15 feet above the road at a point 25 feet out from the center of the median, as indicated by the points on the illustration. Negative 25, 15, and 25. And it's supposed to say 15 over here, but it says 5. So the first thing they want you to do is create a quadratic function for the arch shape. So they want the formula, and then use the function to find the height of the bridge where the bike lanes will be 35 feet out from the center. Okay, so the bike lanes are going to be somewhere over in this area. So pause it, try to figure it out, and come back. And if you can't figure it out, don't feel dumb because, you know, hey, I'm teaching you. All right, so they provided this in 2 different forms, factored form and vertex standard form. Now this provided us with the zeros, negative 50, 0, and 50, 0. So since the zeros were given, factored form makes the both sense. So I don't know why they gave us vertex or standard form. This is the same thing, okay? We're going to use factored form, okay? So factored form is written as f of x is equal to negative 0.008 times x plus 50 and x minus 50, okay? This 0.008, I'm not sure where it came from. I really don't know. But let's come down here and look. This is the standard form this is the factored form for this problem, okay? So they took our coordinates and plugged them in because this is x1, this is x2, okay? So this one is x sub 1, this is x sub 2. So they just took the information we had here, plugged it in down here, and then they wrote it in a simplified form because 2 negatives make a positive. So this is the formula that they wanted us to write. Okay? So the easiest way to do this was not this, ignore this garbage, was to do factored form. Okay? And it's written as this. We don't know what a is yet, so ignore that garbage. Now what we need to do, I guess, to find this a, is to substitute in another known point. They used positive 25 and 15, which makes sense because positives are easier to work with, and solve for coefficient a. So now we're going to figure out what that a is. Okay, so we have this formula that we're using, f of 25, because that's the x value that we're using, is equal to, we still don't know a. They changed it to z, or maybe I just mistyped. You know, that could be an option. X plus 50, our first x is 25, and x minus 50, oh, sorry, it's just x, so 25 plus 50 and 25 minus 50, because we're using this point right here, equals 15. That's our y, okay? So that's how they got all of this was I used this point, plugged it into this formula. All right. Now we're just going to simplify. So you have to take this and distribute out all the garbage, right? And that's going to give us f of 75, because 75 times negative 25, I guess that's this stuff, is equal to 15. Let's make sure it's this stuff. So if we have 25 plus 50, oh, you know what? We don't have to distribute because we don't have any x's. 25 minus 50. So 25 plus 50 is just 75, and 25 minus 50 is negative 25. So that's where that came. This one just came right down here. They just simplified. That's all they did. Okay. Let me erase that so you can actually see what's happening here. All right. Now, if we take 75 times negative 25, I'm guessing we're going to get that negative 1875. Let's double check. Clear, clear, clear. 75 times negative 25 will give us negative 1875. A is equal to 15, because remember, we're solving for A. This should have been an A. This Z up here should be an A. I'm an idiot. Okay. So A is equal to 15 divided by negative 1875. We're dividing both sides, which is where we get our negative 0.008. Okay. So our final formula looks like that. That's how we created the formula for number 1. Now we're going to move on to number 2. So use the function to find the height of the bridge where the bike lanes will be 35 feet out from the center. So we take our formula that we created, and we're going to get a point that's going to be somewhere in here that's going to be x is 35. We'll come over here to the positive side. So x is 35, right? And y is something, but we don't need to know what y is because we only need the x1 values, okay, and the x2. So over here, x2 is negative, x1 is negative 35, and x2 is positive 35. Does that make sense? Okay, so we have f of 35 is equal to negative 0.008. This is the formula that we got right here, times x plus 50 and x minus 50. So it's not even x1 and x2. It's just x plus 50, x minus 50. So 35 plus 50 is 85. 35 minus 50 is negative 15. Do all this math together and you'll end up with 10.2. So the y value for each of these is 10.2. I hope that made sense. Okay, here are practice question number 1. This is at the end of the lesson. You'll just want to jot your answer down so you can fill it in later. Annie is expanding the flower bed in her backyard. Currently, there is a 7-foot by 5-foot rectangle in the middle of the yard. She would like to expand the area of the flower bed by 60%. How many square feet will be added to the flower bed? Round your answer to the nearest tenth. So pause this, try to figure it out, come back, and we'll work through it together. Just going to do all the steps from the previous problems we did like this, and hopefully we'll come up with the right answer. So she's making a flower bed. So we need to find the square footage for the flower bed, for the original flower bed. So that's just length times width, which is 7 times 5, which means the whole flower bed is going to be 35 square feet. Okay? That's how much we're working with for the whole area. She wants to make it 60% bigger. Okay? Now here's the thing. Before, they would go like 7 plus x times 5 plus x equals, because they wanted like to know the borders for like a rug. Okay? So you can do that. You can be like 7 plus x times 5 plus x is going to be equal to 35 plus, you want the whole value of the current rug plus an extra 60% to get the new rug. Okay, so you can do that like this and get the side measures, but they just want to know how many square feet it is. So this is working harder, not smarter. What we really need to do is 35 times 100% plus 60%, and that's going to give us our answer. You don't have to work that hard, okay? You don't have to do all of this garbage. So 35 times 1.6 is 56 square feet. Your answer is going to be 56 square feet. Okay, and this is reasonable because let's stop and think. If you don't care about this being reasonable, you don't have to listen to this. But if we have 35 square feet originally, half of this, okay, because we're dealing with 60%, half of 35, I should be able to do, but I don't trust myself because you know you're listening to me. Half of it is 17 and a half square feet. So if we did, let's say 35 plus 17.5, that's 52 square feet, and we know it's going to be a little bit bigger than that, so that's a reasonable answer. That's going to be the correct answer, okay? I'm teaching you how to do math the stupid way, the way I do it. Here's quick check question 1. I will not give you the answer to this, but I will show you the steps to take to find it. Hassan wants to add a border to a photo he took before he frames it. The final area of the entire framed picture will be 96 square inches, okay? So when it's done, the total area is going to be 96 square inches, okay? The length of the picture is 10 inches, and the width is 6 inches. Which of the following is the width of the border? Okay, so what you need to do is first you need to figure out, this is the final product. This is framed, okay? This is how much it's going to be at the end, okay? This is just the photo, okay? This is just the picture. So 10 times 6 is going to be 60 square inches. So that means that the final product has 96 square inches. The actual picture is 60 square inches. So the difference between the two is going to be 26 inches. Okay? Can you see that? So, which of the following is the width of the border? This one is, see, this is not fair. They haven't given you anything like this yet. So I'm a very visual person. So here's my picture. And this is 60 square inches. Okay. Here's my border. Woo! That's a beautiful frame. That's custom right there. And this one is 96 square inches. Okay. So it doesn't tell us if the picture is square or not. So let's see. I don't think 60 is a perfect square. I don't think you can have a perfect square. 60 square root. Oops. Square root of 60. Yeah, that's not a perfect square. So it's not a perfectly square picture. We know that the difference between the two is 26 inches. So you're going to have to try to figure out which is the width of the border, which is the distance from here to here. Okay. How wide is this space here? This is so convoluted, and it really annoys me because they haven't taught you how to solve this. So logically, if this is 9 inches, then that's 9 inches and 18 inches. 18 and 18 is 36, so this one's out because 36 inches just here doesn't leave any room for a border here. Okay, so 36 inches is obviously out. It can't be 9. Okay, so if it's 1 inch here and 1 inch here, that's 2 inches. That means the border here has to take care of 24 inches. So it's like 12 inches here and 12 inches here. If this is 3 inches and 3 inches, that's 6. So that's 10 inches and 10 inches. If this is 4 inches and 4 inches, that's 8. So that gives you 9 and 9. So whichever one you think is the most reasonable for a frame. Okay. Next part of the lesson, parts of a graphed quadratic equation. So here's our example. This is what it looks like. A parabola is the shape of the quadratic graph. It's this nice little scoop. Okay. The vertex is right here. It's the absolute maximum or minimum height of the parabola. If it's shaped like this, then it's a height. Okay. The intercept is where the parabola crosses the x or y axis. This one is both an x and y axis cross-intercept. And algebra is an absolute pain in the butt. So this is an example to walk you through picking out all the points on the graph. This part of the lesson gets much easier, so you can take a breather. The football team's kicker is taking practice kicks. The graph shows the path of the ball after it is kicked from the ground. The ball initially is kicked from the ground. This is represented by the point 0, 0. So this is where the ball is when it's initially kicked. After the ball is kicked, it travels upward and reaches its maximum height of 56.25 feet in 1.875 seconds. From its maximum height, the ball returns to the ground. The ball will land on the ground 3.75 seconds after it is kicked. Okay, so this is time in seconds. This is height in feet. What does the vertex point 1.875, 56.25 represent in this example? The vertex shows that the ball will reach its maximum height of 56.25 feet 1.875 seconds after it's kicked. What do the x-intercepts represent? The x-intercepts represent time. In this example, there are two of them, when it starts on the ground and when it comes back and hits the ground again. Sometimes an intercept is not relevant or applicable to a specific problem, even though it is part of the graph. So in this case, a volleyball player serves the ball during practice. The graph shows the path of the ball from the moment it leaves their hands to when it hits the floor on the other side of the net. In this example, the volleyball does not start on the ground, okay, when it is hit, but rather at the height of the volleyball player. It starts right here. This is a tall volleyball player. Because of this, the first x-intercept, negative 0.1650, is irrelevant because it represents a point in time before the volleyball begins its flight. In this scenario, the y-intercept, which is at the coordinates 0, 6.2 right here, reveals the actual height at which the ball starts. This point means nothing, this x-intercept right here. Okay? What does the vertex point 1.094, 25.341 represent in this example? The vertex shows that the ball will reach its maximum height of 25.341 feet 1.094 seconds after it's served. What does the x-axis represent? The x-axis represents the time. The second x-intercept right here at 2.3520 represents the time it takes the ball to return to the floor level after it is served. This x-intercept is irrelevant. In this example, both x-intercepts are not needed to interpret the context of the graph. Instead, the y-intercept is used to understand the scenario represented by the graph. Here is question 1. Luca kicks an acorn off a ledge while hiking. The following graph shows the trajectory of the acorn. What does the vertex mean in the context of the graph? Okay. What does this vertex mean? This one's all you. I didn't put a picture on here, but you solve it. Pause it and come back. The vertex represents the acorn starting at a height of 15 meters before it's kicked. Okay? This is where it's starting because it's up on a cliff. Luca kicks an acorn off a ledge while hiking. The following graph shows the trajectory of the acorn. What do the two x-intercepts mean in the context of the graph? Figure it out. The x-intercept at negative 1.75 and 0 is not relevant to the context of this scenario. The acorn's never here. The acorn starts here. Okay? The x-intercept at 1.750 means the acorn will reach the ground level 1.75 seconds after being kicked. This is a really high cliff. Okay, here's practice question number 2. Make sure to write your answer down. An object is thrown into the air. Use GeoGebra to graph the situation using the formula y equals negative 4t squared plus 10t. What is the maximum height the object will reach in feet? So go do this, figure it out, and then we'll do it together. Oh, start the calculator. Come up to your input, type in y equals 4t squared plus 10t, and it didn't like it, probably because we're using t, so we're going to go back to just x's. GeoGebra does not like weird letters. Okay, there we go. Now it gave us a nice pretty problem, and it wanted to know the vertex, I think. So if we come down here, There we go. The vertex is negative 1.25 and negative 6.25. So it says an object was thrown into the air, and it says that the maximum height the object will reach in feet. And guess what? I didn't get a maximum height, so let's go see if I can fix that. Hey, guess what? It helps if you put the negatives in where the negatives exist. Oh, it did it now. And there's our extremum. Instead of negative 1.25, it's positive 1.25. And instead of negative 6.25, it's positive 6.25. I'm a genius. In this case, the height is the y-axis, so the only number we need is 6.25. Da-da! Here's practice question number 3. Zek, and what kind of name is this? I typed this right. Like, yuck. Zek tossed a water bottle into the air from the top of his shed in the backyard. Get off your shed, Zek. Use GeoGebra to graph the situation using the formula y equals negative 46t squared plus 30t plus 8. When will the balloon hit the ground? Round your answer to the nearest tenth of a second. Go ahead and do that. Make sure to clear your graphs. Let's enter our next one. It's y equals, and guess what I learned in my lesson? Negative 46, not 3, x squared, not t, because it doesn't like weird letters, plus 30x plus 8. Okay? And it gives us this graph. And it wants to know when it's going to hit the ground again, which is going to be this x coordinate, which is, and it wants it rounded to the nearest tenth, so it's going to be 0.9 because it's 0.85. So the answer for this is 0.9 seconds. Here's practice question number 4. A swimmer's dive is modeled in the graph in which x is the distance from the pool's front wall. So this is distance. It always helps to just label stuff so you don't get confused later. Okay? And y is the swimmer's vertical position. This is vertical, which is nice because you know it's actually vertical. How deep was the swimmer's dive? Okay, the swimmer's dive was, speed round, pew, 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 pew. Negative 4, or in this case, just 4 units deep. Okay, you don't need to write negative because we know, well, maybe it'll take negative. I don't know. You never know on these stupid things. I would try negative 4 first, and if it doesn't like it, then put in 4. It doesn't matter because you don't get graded on practice anyway. Quick check question 2. May's class is testing their egg protection contraptions by dropping them off the roof of their school. Use GeoGebra to graph the situation using the formula y equals negative 16t squared plus 40. Which of the following correctly interprets the height of the school's roof? So first, go to GeoGebra and graph this, and then it wants to know the height of the school's roof. Okay, so that's going to be where they drop their eggs from. Okay, so if you stop and think about it, if we have our little graph like this, okay, the eggs are going to be falling, so it's going to be a parabola something like this. Okay, this x coordinate is going to be irrelevant because the eggs don't start there. The eggs start up where it crosses the y-axis. This is the number they're looking for right here. This is the height of the school's roof. Okay? Quick check question number 3. Luca is in a culvert below street level. Don't do that. You're going to get drowned or murdered or something. He launches an object at an upward velocity of 40 feet per second. Use GeoGebra to graph the situation using the formula y equals negative 16t squared plus 40t minus 5. How far above or below street level is Luca's initial launching point? Okay, so again, think about it. You have this graph. Luca is in a culvert below street level. That means he's down here somewhere, okay? And he launches an object, and it's going to go up, and it's going to come back down, okay? So your graph's going to look something like this. So how far above or below street level is Luca's initial launching point? It wants to know this number, where Luca started from, where he initially launched from, okay? You can do this. I believe in you. We're almost done. It's just stupid at this point. Here's example 1. A hawk swoops down from its perch 30 feet in a tree to catch field mice. It follows the function h of t is equal to 6t squared minus 24t plus 30, where t is the time in seconds and h is the height in feet. Graph the function to identify when the hawk will be at its lowest height or closest to the ground. So you can see here, this is where the hawk launches from. This is where he's at his lowest, which is 6 feet, okay? And it's at 2 seconds after he launches, he'll be 6 feet from the ground, which is the lowest point. Okay, that's the whole shebang. That's it. And then apparently this is just garbage. Here's question number 1. This is your turn. And I had deleted all of this stuff, but it kept it. A golf ball, here it is. A golf ball is hit from the ground at an upward velocity. Graph this situation using the function h of t is equal to negative 16t squared plus 45t to determine when the ball will reach its maximum height. Go do it. Come back. All right, clear your crap. Let's get rid of stuff that we don't need. Input, remember f of x and y are interchangeable, so I'm just going y. Negative 16, use x. It doesn't like weird numbers. So instead of t, it's x. Negative 16x squared plus 45x. And here is your real beautiful little graph. You can see it goes clear up. Woo-hoo-hoo-hoo-hoo-hoo, really high. And it wants to know what the maximum height is, which is this point right here. And the maximum height is 31.640625. Okay, so our answer is, we got 31.64 and they got 1.406. Oh, they wanted the time in seconds. Ha 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 ha, I'm a genius. So here's the same question, but they want to know when the ball will return to the ground. So we'll jump over to that problem again and look. Let's come down here and see when it's going to land. It's going to land at 2.8125 seconds. Practice question number 5. The trajectory of a balloon is modeled in the graph in which x is time in minutes. So this one is time. And y is height in feet. Height. This is hard to do. Okay. What is the height of the balloon 3 minutes after being released? Speed round. Do, 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 do. Follow it up. And it crosses right here. So 3 minutes after being released, the balloon is at a height of 14 feet. Quick check question number 4. Which of the following scenarios would use a quadratic equation to solve? Again, they didn't ask you any of this, but we can do this. We can. I will help you. The trajectory of a balloon that rises 2 feet per second is modeled to find how high the balloon will be in 5 minutes. Okay, so if we had a graph, the balloon would go up, and it wants to know where it's going to be in 5 minutes. Okay. A child places a quarter in a piggy bank every week. So that would be like, here's your chart, and every week it's got a quarter, so it's just growing like that. A coach models the trajectory of a ball to find how high the player is kicking the ball. So if you're kicking a ball, it starts here and the ball goes up and it comes back down. And an accountant models the growth of a savings account that doubles every month to find how much will be in the account in 10 years. So if your account is doubling every month, it's going to look like that. All right. Here's quick check question number 5. A sports analyst graphed the trajectory of a soccer ball that was kicked by a goalkeeper. In the graph, x is the ball's distance from the goalpost. So this is distance. And y is the height of the ball in meters. And this is height. Height is a really weird word. Height. Okay. What was the goalkeeper's distance from the goalpost when the ball was kicked? So if this is the goalpost, okay, this right here is the goalpost. Where was the goalkeeper standing when the ball was kicked? Okay? You can do this. I believe in you. And sarcasm is what makes the world go round. And it makes these lessons happen. And this is what Canva provides for me when I put in sarcasm. I particularly like this one. It says sarcasm loading.